In this video, we're going to be looking at the laws of logarithms with some example questions. So the first kind of thing to know about logarithms is that log base b, c, is equal to a is exactly the same as saying b raised to the power of a is equal to c. So when we have log b, c is equal to what, then we're basically asking b raised to the power of what is equal to c. And then we have three main rules. So we've got the multiplication rule, which is when log whatever base b times c is equal to log base, the same base as before, so base a in this example b, add log base a c. And then we also have the division law. So if we have log base a of b over c, that's equal to log base a of b minus log base a of c. We have the power rule, which is if we have log base a of b raised to the power of c, then we can bring that power forward to the front, and we have c times log base a of b. And then a final thing to note is that a log to the base of a of a is equal to 1. So if you have log base 5 of 5, then it's just equal to 1. So we want to write these as a single logarithm. And so for part A, what are we going to do? Well, we've got two logs. They're to the same base, that is 3. And so we're going to use our multiplication law. So we have log base 3 of 6 add log base 3 of 7 is just going to equal log base 3 of 6 times 7, which is log base 3 of 42. And then we're going to do the same for part B, but it's a different rule this time because we've got a negative here, not a positive. And so what we're going to use our division law. So log base 2 of 15 minus log base 2 of 3 is equal to log base 2 of 15 over 3, which is equal to log base 2 of 5. So our next question, we're using a bit of algebra instead of just numbers here. So we want it in terms of log ax, log base ay, log base az. And so what are we going to do? Well, we've got a mixture of multiplication and powers in this first example. So we have log base a of x squared y z cubed. And so we want to break this down. So we want it in terms of, log base a of x, y, and z. And so we can use our multiplication rule to do this. So this is equal to log base a of x squared add log base a of y add log base a of z to the power of 3. And then we can use our power rule to bring these powers down. So this is just equal to 2 log a of x add log a of y add 3 log a of z. And then for part B, we can see that there it's going to be the division rule here because we have x over y. And so we can break this down into log a x minus log a y to the power of 3. And then we know that this we can bring this power down using the power rule. So log base a of x minus 3 log base a of y. And that's our final answer. And now this last one looks a bit more tricky because of this square root, but don't panic, it's exactly the same thing. We've just got a mixture of multiplication and division. So we can see that we have log base a of x add log base a of root y, which is exactly the same as y to the power of a half, minus, because it's all divided by, log base a of z. And so we're going to use our power rule and bring that power forward. We have log base a of x add 1/2 log base a of y minus log base a of z. And so now we have another example which solve the equation. And so let's have a look at this. To solve the equation, you ideally want to get it into one logarithm. One logarithm is equal to something. And so in this case, we have log base 10 of 4 add 2 log base 10 of x is equal to 2. Now, to use our multiplication rule, we need to have the same constant outside the logarithm. And so, there's a problem here. 2, we've got 2 on this logarithm and 1 here. And so what we're going to do is we're going to use our power rule to bring that 2 up to the x. And so we're going to have log base 10 of 4 add log base 10 of x squared is equal to 2. And now we can use our power rule. So we've got log base 10 of 4x squared is equal to 2. So what are we going to do now? Well, if you remember, log base b of c is equal to a is exactly the same as b to the power of a is equal to c. So we're going to apply that here. Okay, yeah. So basically saying 10 to the power of 2 is equal to 4x squared. So we're saying 100 is equal to 4x squared. So 25 is equal to x squared. So x is equal to plus minus 5, right? Well, this is not exactly the case because within a logarithm, the value has to be strictly positive. And so we can't have a negative value. If we had minus 5 in this expression here, it will be a negative value. And so x is only equal to 5. X is not equal to minus 5. Okay, so we've got a final example. Again, it's to solve the equation, and we're going to do what we did last time. So we're going to make it into one logarithm. So, we can see here that the constants on the outside are exactly the same. We've both got 1. And so we can use our division rule to immediately kind of combine these two logarithms. So log base 3 x plus 11 over x minus 5 is equal to 2. Then we're going to use the same rule that we used before. 3 to the power of 2 is equal to x add 11 over x minus 5. So this is equal to 9 is equal to x add 11 over x minus 5. And we can just times these two together. So we've got 9x minus 45 is equal to x add 11. And then we've got 8x is equal to 11 add 45, which is 56. And then we're going to do x is equal to 56 over 8, which is 7. Okay. And that is kind of the procedure for logarithms. The concept of a log might be, extremely confusing at first. What's this kind of number? What's it representing? But, as you get along in the course and you begin to apply it to certain things like modeling, the applications become a lot more clear and it becomes a lot more intuitive to understand.